All right, welcome back. We are GAME3001. That's artificial intelligence at George Brown in the summer 2021 semester, and it's week 1, part 3 of our broadcast. Right now, we're doing our lab. We've already done a lab, so you guys are lab 1B, which is totally cool. And let's talk about what we're going to be doing today. So here's lab 1 goal. So what we want to do is we want to talk about Git and GitHub briefly, how to use Git and GitHub, how to put things up on Git and GitHub, all that kind of stuff. I'm going to introduce you to Sdl Engine version 0.25. This is our assignment framework that myself and Alex and other people here at the George Brown have created. A bit of refresher on Sdl and how it works. We're also going to understand how singletons work. And of course, I want you to download the framework from github.com/George Brown College/Sdl_Engine. So if you haven't had a chance to do that, please download it now. Don't clone it, just download it. And I'll go into the details in a second. We're also going to learn about Dear Am Gui, which is a programmable immediate mode UI. Okay, something that we're going to be using for to adjust our metrics and to have real-time effect of our scene. All right. And also, we're going to talk about how to submit labs. You're going to make a private repo, and you're going to include me as a collaborator. By the way, in future, you're also going to include Alex as a collaborator, and I'll give you his email address as we come closer and closer to the time when Alex will join us in the mid-semester timeframe. All right, we're going to create a zip archive of our project with no garbage files, and we're going to submit onto Blackboard. So that is what Lab 1 is all about. How to do stuff is what it is, right? And a little bit of code, very, very small amount of code. All right, any questions so far before we begin in terms of our lab goals for anybody there? All right, let's move on. So first, what we want to do is I want to talk about Git and GitHub. And I'm going to bring up a little diagram that I made earlier today. It looks like this. So let's talk about Git and GitHub a little bit. And this is kind of a refresher, right? So I want to talk about this as a refresher. So remember what happens, right? We have, when we're developing stuff, what we have is we start off with a local machine. We start programming some stuff, our code, for our game. And then what happens is, or what happens when, as an example, and this can happen, you don't know what you did. Everything was great just a moment ago. You added a feature, and then you broke your build. And it happens a lot, right? Where you kind of come in and you go like, I don't know what happens, but this is totally broken. It doesn't work, right? And you try whatever you can. You try Control-Z. You try a bunch of different things, but there's nothing you can do to revert back to a working state. This happens to a lot of us. It's happened to all of us in time, right? GitHub download link. Oh, sorry. That take a look at the guys. Take a look at the on Blackboard. On Blackboard here. Sorry. While I continue that. If you look at Blackboard, if you look at labs, under labs, you'll see that there's the assignment framework that's right at the top. Okay, so under labs on the left, you go to assignment framework, and that's your stuff right there. It's always going to be there forever. Okay, and I got this little big X here. Let's go back to my annotation and clear my annotations. There we go. So going back, like what I was saying. So let's suppose then that I'm back in my code, and I want to somehow, be able to capture my changes. So there's a couple things we do, right? One thing we do is, and this is bad practice, we use Google Drive, right? We're like, hey, cool, I can use Google Drive. I can mark my changes as V1, V2, V3 with all my versions. And worst case scenario, I can revert back. I can just go to my previous save files and open them up. That's fantastic. But are you going to make version changes every single feature that you upload, or that you update? Maybe not. And what if you've worked for hours and you haven't updated anything? What if you've worked for even 10 minutes and you've got a critical thing, you have this brain an inspiration in your brain, and you figured out what to do. You found a solution in your head, you didn't write it down, and you quickly fixed it. It worked for a second, and then you moved on to something else. And when you came back, it was broken, and there's nothing you can do to get it back. You can't even remember what you did, right? You can't capture that with versioning with Google Drive. It just doesn't work, right? So of course we need some kind of version control system, and there's different ones. The one I'm talking about today is a centralized version control system, right? Or sorry, decentralized, that works on your local machine. So what I do is I get my repository from GitHub, as an example, or I make one on GitHub, and I work locally on my machine. And when I'm done working locally, I push everything up to GitHub. That's how we work typically with Git and GitHub. There's also another version control system we use as game developers called Perforce. As an example, where I'm sure you and Philip, if you're working with him on game production 2, he's making you use Perforce. That is a centralized system where everything is up on the server, as an example, and you don't make a local copy. What you're doing instead is you're working on the server, right? There's disadvantages to both. However, the idea here is that we want to make a repository locally. We want to initialize the repository. We want to add files to the repository. We want to create a first commit, which is like a snapshot of your code. So we want to capture what your current state of code is. We want to connect to a cloud service like GitHub. There's GitHub, Bitbucket, GitLab, a bunch of things online. Even for Perforce, there's also online servers you can go to, right? And then you want to push your files for the first time into a repository up online or repo. Note that on GitHub and in Git in general, you don't have direct file access like you do when you're using Google Drive. In Google Drive, you can actually create new folders and remove files and all that kind of stuff. Not so in GitHub. In GitHub, you clone your whole repository and you put it up. If you make a change, it becomes a commit, a new capture, because you always want to be able to revert back to the previous state of your code. Okay, so that's kind of the process. The terminology as a refresher is when we push to GitHub, we're actually uploading your entire repository. And when you're pulling from GitHub, you download the entire repository back down. When I say the entire repository, if you've only made one change, you only push up the files that have changed. And if there's something that's changed online by somebody else that's working with you, you pull down only the files that have changed, okay? The 3 reasons why you'd use GitHub, Git and GitHub, and I'm going to ask you this on your mid-semester test, are you use it for backup. Because if I use GitHub, if something happens to my machine, as an example, and it breaks, so let's say, for example, my machine breaks, but I put it up on all my files up on GitHub, I have a backup, right? So that's the first reason why I'd want to use Git and GitHub. The second reason why I want to use it is version control. I mean, I can go from one version to the other. I can add a feature, and if I don't like that feature, I can revert back. Or if something didn't work and it broke 5 things, I can always go back to the previous version, or at least look back, even if I don't want to go back. And it keeps track of everything that I've changed from one version to the other. So versioning is huge. And the last feature, which I think is very important as well, is collaboration. I want to be able to share my files with you. You want to be able to share your files with other people, and that way we can work together. So this happens once, this kind of thing. And what we also want to do is we also want to do this many times. So where it says once, we create a repo, all this kind of stuff the first time. But our workflow looks like this. I want to add a feature. I add all my files that have changed. I create a new commit, which is a new snapshot of my current file state, right? And then I push my changes to the remote, which is GitHub in this case. And I keep doing that over and over again. I have a bug fix. I fix my problem. I add all the files that I've changed to GitHub. I create a new commit, and then I push my changes to the remote. And I keep doing that over and over again. And so what the remote keeps track of, and even your local machine, it keeps track of all the iterations and the history of your development, right, up on GitHub and locally on your machine. And this is why Git and GitHub are so popular. In fact, I would probably be not hesitant to say that Git and GitHub, that combination, is the most popular version control system for software engineers today, right? Whereas Perforce is very popular with game dev, right? As an example, Git and GitHub, that combination is the most popular across all other disciplines for computer science. All right. And also just to remind you that GitHub is owned right now by Microsoft. So when we create a remote, we have to name it. And usually the name is called origin. All right. And origin, the remote has a path. Usually the path goes like this. The first part of the path is https://github.com. The second part of the path is the name of your account. In this case, George Brown College. The third part of the path is the name of your repository. For example, in this case, GAME3001-M for summer 2021 week 1A or lab 1A or whatever you want to call it. Okay? That is the total path for your remote. And when I push to this path into the main branch. The way the main branch works in branching in general, you make a first commit. And then let's suppose that Tom made a first commit and he added another feature. He makes another commit. But let's say, for example, that Adam, another user, right, takes this commit and makes a new one from it and a brand new branch. He's adding a feature branch. We can say right now at this point, without moving forward from here, that Adam is ahead of master or the main branch by one commit at this point in time right here. But let's suppose that Tom, for whatever reason, wants to continue adding features on the main branch outside of what Adam is doing. So he adds a new feature and another bug fix and a new feature, right? And Adam, he fixes his new feature up. And what he does at the end is he merges his feature with Tom's main branch, and they come to a commit that's common between them. And this branch here closes. So there's no more branch. Okay, this is what typically happens. You merge everything back into the main branch. When you do this, a lot of times, one of the biggest complaints about GitHub is you have merge conflicts. Why is that? Because what ends up happening for us is, if I have a file that I'm working on, for example, game.h, and you're working on a file and it happens to be game.h, and you add functions to that file and I add functions to that file, which functions are we taking? Mine? Yours? Both? Which one? So that's where we have to get together and do a merge conflict where we decide which features we're going to take from your commit and which features we're going to take from my commit. And we put them together and we create a brand new commit that has both of the changes that we include from both of us. That is definitely one way of doing it, but it's more complex. Another way to do it would be Tom is the director. Let's suppose I'm the Git director and Adam he adds a feature, and what he does is he does a pull request. He adds some stuff on his own to his own, he forks the repository, he does his own feature, and then he does a pull request. And what Tom does is he merges the Adam stuff into the main, the main branch. He does the merge conflict on his own, all right, or the merging. The other way to do it is Adam never touches the main branch at all. He doesn't even do a pull request. He doesn't do a merge. What he does is he takes this commit right here and works off of it. He adds his own files, makes that feature work, and then he meets with Tom, and then he gives Tom the files, and Tom uploads everything to GitHub. That's another way of doing it, where Tom is the director and Adam is someone who's working for Tom. Okay? And the last way of doing it is Tom works, and then Adam works, and then Tom works, and then Adam works. And the way that works is Tom adds a feature, Adam pulls the feature. And then Adam works on a feature, and then Tom pulls Adam's stuff. And then Tom works on some stuff, and then Adam pulls from Tom, and it keeps going back and forth. And that's closer to how it works with Perforce. Perforce is I work, and then you work, and then I work, and then you work, right? I have a question from Nahar. It says, yeah, Git and GitHub are definitely two different things. Nahar says, can we still use programs like Gitkraken to push and pull from our GitHub repo? Sure. But you're going to find that Visual Studio is a lot easier to use as a that basically does everything for you. You don't need to have separate user interfaces right now. But if you really want to, you can. In fact, it doesn't really matter to me how you put your stuff up, as long as you show all your work, all your iterations. Every time you add a feature, that you're able to show me that. Okay, anyone have questions around the workflow? Local machine is that runs Git, and GitHub is a separate cloud service. All right, so hopefully you get this. I'm going to be talking about this workflow over and over again, and you need to know about version control anyway, because that's one of the outputs from this course. And you're working with version control with Philip either way with Perforce, which is pretty cool. All right, so that is that. Let's move on. So we've covered, if I go back to this, this is a check mark. Okay, so this is done. And I meant to do this. All right, so Git and GitHub down. Okay, let's talk about Sdl Engine and what that is. It's a construct that myself and Alex and other professors at George Brown have created. And again, what we talked about is, if I go back up to our GitHub repository online. So let's do that. So I'm going to go to github.com / not Centennial / George Brown College. I'll be okay. And I go to here. You're going to see that I just did my lab earlier, which is lab 1A. What I want to do is I want you guys to pull Sdl Engine. And notice I also have a pinned repository up here. You can always pull Sdl Engine from here, okay? If I go here or here, let's go to this one. You can see that, again, there's a couple of things you can do with this one. If you wanted to, you could fork it. If you have a GitHub account, you can fork Sdl Engine. And what would happen is, you would have a copy of the current state of the engine in your repository. And then what you could do is, if you really wanted to, you can create your own updates and send them to me as a pull request. I got a couple of them already, right? And if I like your changes, I can add them in. That's how that would work. Or if you're just working on an assignment, you can just download the code. So if you click on code and you click download zip, please do not clone. If you cloned it, then you would try to add to my commits, and that's not going to work. So please just download the zip file. Or one more thing you can do is, if you go to releases on the right, then you see that there are 7 releases. The latest release that got up today, right, which is releases version 0.25. And I've talked about what I've added as well as some known bugs. All right, so please make sure you grab the latest release. I probably should rename this thing so that it says the same thing, right, as the other one. So I call these Sdl Engine V024, and this should be Sdl Engine V025. I'll just do that now since we're here. All right, there we go. Awesome. All right, so if you download the source code from here, it's the same as if you clicked onto this and you click download. But a lot of times this is just quicker. If you click this, it'll take you here and you can download the source code. Okay? And you can also see specific release information. All right, so that's how you get it. Let's do it. I'm going to download the release. I'm going to download the source code. So it's going to download a zip archive. There it is, right? Right now it's 8.5 megabytes. Not so bad. It's pretty small, right? And what I'm going to do with this, I'm going to grab this zip archive, I'm going to cut it, and I'm going to go to my desktop, and I'm going to go to GBC GAME3001, go into M2021, and I'm going to paste it. And then I'm going to use 7-zip and unzip it, right? Extract here. Now, if you don't have 7-zip, right, notice that I have a menu that's a context menu. I recommend it. So go grab 7-zip from this link. I'll put this link onto Blackboard. So again, we'll put this under useful external links. So web link, and we'll say 7-zip download. Okay, so that's there under external links. But if I right-click now and I go to 7-zip, I can extract to Sdl Engine 0.25. I can delete this now. I don't need it anymore. And what I can do is go into Sdl Engine 0.25 and just rename it. By the way, notice that when I go in here, it's this. But I can rename this to Lab 1B, which is you guys. Lab 1B. If I double-click on Lab 1B, I can see my folder structure. And I can double-click on template.sln, which is my solution file. And when I do, it pulls up Visual Studio. Okay, a couple of things when we start to let you guys know about. Number one, notice it says debug is the configuration x64. We do not want x64. Please change this to, when it gives me a chance to do it, because ReSharper is working, change it to x86. That's number one. The first change you make whenever you download the files from our site online. Okay. Next, I want you to right-click on the solution template, and I want you to retarget your solution. So where it says retarget solution, please do that now. It's going to pull up a dialog box that looks like this. When we retarget our solution, it looks at the latest SDK for Windows that's installed on our system, and that's the one you want to target, not some other random one. In other words, my system might have a different SDK version than yours. I'm running Windows 10 Pro. Maybe you're running Windows 10 Home or something else, education, right? Which is also an option. Maybe my version is more updated than yours is, or yours is more updated than mine. You want to retarget your SDK version here and press OK. I'm doing it even though I know it came from me. All right, now that I've done those two things, the next step, whenever I share with you guys, is run it and see if it can run. Okay? So this is like step 3 in the download and kind of sharing process. It's going to take a second to do that, build and run. And when everything is going well, as an example, right? Then what we have is this. A couple things to note here. I'm going to take you through a tour now of the entire engine. It's going to take some time. So again, try and have patience. I'm going to go very slow, or as slow as I can anyway. If you have a question, please post it on chat. Whether you're watching this live on YouTube or whether you're on Zoom, please let me know so I can answer your question. So notice on the top left corner, it says Sdl Engine version 0.25. If it says something else, you've downloaded the wrong version somehow. Okay. I have this little spaceship and it has a line in front of it. This little line in front of it is line of sight. Right now, it doesn't see anything, and it's not going to. I have a couple of fonts that I'm using, right? And these are labels that I have here. A start scene, some kind of label to tell you what to do, an instruction, and the start button. If I click the start button, it's going to take me to my placing. Notice it switches on the left. On the left, it tells you start scene activated. I activate it, and then now it's placing activated. So I move from my start scene to my placing. When I do, it cleans the scene up. And take a look at the memory on the right here. This is a not wholly accurate memory count, but it can tell you a couple things. Diagnostic information about how long my program has been running, as well as how much approximate memory I'm using. Right now, I'm using about 40 megabytes of memory to run this thing. Right, cool. If I click next again, you're going to see that it again has slightly lower than 40 megabytes because I removed some things from the scene, right? And I have a restart button that if I click, I go back. Okay? Clicking in the middle of the button works nicely. Clicking on the side of the button, I got to work on it. But notice that there are a couple of other additional things here. I have a little plane with some propellers that's kind of animated, and I have this little animated guy. If I connect an Xbox controller right now, so I'm doing that, you guys can't see it, but I'm doing it for other people on YouTube as well. If I connect an Xbox controller, as soon as I do that, notice that it says on the left that I've added a controller added. If I press the left stick to the right or the left stick to the left, I can change the animation state of my little guy. In fact, I have a full animation system that I've included for you. Again, today we're not covering animation. I'm just covering how to make things work and what the assignment framework includes. All right. There's also a little message here that says press the backtick character. The backtick character is the button below the escape key. If you press that character, it comes up with a little window. This little window is the Am Gui window. Am Gui stands for Immediate Mode UI, Graphical User Interface. Okay, that's what this is. And I have a button and I have a couple of sliders. Notice when I move the slider, it changes the values on the left, right? In other words, I'm making a difference. When I change this, it changes some values. This is good. This window here is just your debug window that you're going to use to modify your scene for your assignment 1. And for all the other assignments. All right. So once I've done that, if I press backtick again, it can toggle this off. If I click on this button right here, this closes the window and I can toggle it back on. And if I click on this X up here, it actually closes down the entire application. I can also turn off the entire application by pressing the escape key. The escape key closes the entire application as well. Okay, so those are the 3 ways to close the application. Let's run it again. All right. One thing to note is if you press the backtick character in your start scene, not in your play scene, it pulls up a different option. Notice that there is a Dear Am Gui Demo right here. If I double click onto it, it shows you a bunch of more options. For example, widgets, basic. Here's what a button would look like. Here are some colored buttons. And what this window does for you, this little Dear Am Gui Demo window, it's quite amazing actually. What it's doing is it's giving you every possible widget you can possibly think of that you can add into your, your scene. That's what it does. Okay. It also includes things like trees, right? If I want to, I can scroll up and get rid of basic. It has examples of text. So here's colored text. These are all things you can include here. You can program here on the right-hand side to do, kind of debugging information on the left-hand side. That's what this is for, okay? Images. So all these images, it can do kind of like a zoom functionality. You can also do other things like plots. So for example, if I want to do a plot, I can do that. Here's, for example, frame times. It'll show you that kind of stuff. A histogram, simple counting functions, different kinds of lines you want to draw, some kind of progress bars. You know, you can do all this kind of really cool stuff, and it's built into Am Gui, right? So why am I showing you this stuff? Because I'm just going to escape from here again. If I go back to my, you know, my folders inside of, or my filters inside of my project, under the Am Gui filter, you can see that there is a Am Gui Demo.cpp. Am Gui Demo.cpp has all the information you need, and it says, hey, do not remove this file from your project. Think again. This is a reference for every kind of widget you can possibly think you need for testing and for debugging. And I mean it, every kind of widget you can possibly dream of, right? So if I want to find something like a plot, I can do Control F, and I can just start typing plot, and you can see what that looks like. So create a dummy array of contiguous float values to plot, and then it gives you examples in here of how to create plot lines or a histogram or whatever you need. So here's the examples if you want to create some fancy function to show on the left, like for example, a progress bar. It's that simple. Okay, so please don't delete this file. This is an example for the API. As well, if you want more documentation, and I didn't cover this in the first class, but if you want more documentation about how to use Dear Am Gui, you can just type in Dear Am Gui. And this guy, Okornut, right? He's the guy that is maintaining Am Gui. And if you scroll down, it talks about this entire library, how it works, and what you can do with it. And a lot of detail. Okay, tons and tons of detail about what you can do. Okay, and these are all the things that you can do with Dear Am Gui. All right, so take a look at this for more information. There's a ton of stuff you can do. Am Gui is not just used here in our Sdl engine. Unity uses a version of Am Gui, and so does every other, you know, OpenGL, you know, kind of a program you can think of. Notice that there are something like 6,000 commits right now that have been done. This project has been going on for a while. And if they progress like I do, they have 71 releases right now, as an example. And their latest release is version 1.82. Our version that I've loaded into your files is version 1.71. And that only happened last year. I will update Am Gui as we go. All right, so that is a little bit about Am Gui. I'll tell you more about it later. But so when I run this thing, I have, again, this is what the application will do. I can have this little main window, right? As an example, I can pull up Am Gui, right? Notice it remembered the open state. I can close it up again by double clicking. If I go to start though, it replaces the default window with my own. This is my own stuff that I added in before with a little slider like we talked about. Okay? How did I do this, and how do we make our application work? What is Sdl Engine? Well, one of the things we have to start with is, what are these? Remember that in Visual Studio, and I'm just going to magnify a little bit. I'm just going to go into a different magnification level to make it easier for you guys to see. So I'm going to change my display settings just for a second. I'm going to go into 150% mode. And hopefully this will help you for people who need to see a little bit more. Take a look, right? So these are filters. And the way this looks here in Visual Studio is not the way that it looks on your File Explorer. So the way it works is if I right-click on my solution, and if I look at Open Folder in File Explorer, you can see that I have, in my SRC folder, you can see that I have all my files for my CPP and my .h files all in one folder. There are no subfolders like this. This is a construct that only exists in Visual Studio. it's a helper construct for us, right? So that we can look at, organize our files. But here, when we're working on in File Explorer, everything is one. And this makes it easier for us to port to another machine and so on. So where do we start? Well, let's look at core first. So if I go to my core filter, right, I want to go down where it says main.cpp. So in main.cpp, I'm just going to unpin this for here on the right. In main.cpp, you're going to see a few core libraries that I'm using, and then this thing called game.h. What? What is game.h? Okay, well, let's go there. So I'm going to go back to my Solution Explorer, and game.h is something new, right? It's actually a singleton. And we may have talked about singletons together when we were doing fundamentals with you, or not. But one thing to note is this. Think about a singleton as you can only ever will have one. Just like, again, I like to think about it as, the movie Highlander. There can be only one, right? And it's true. There can only be one instance of any of the singletons that I've created. The singletons that I've made for you, for the most part, except for my font manager, I have a bit of a bug there, is they're all magic statics. And this is what they look like. They have an instance function. But notice that all singletons, and you're going to see more than one, have both the constructor and the destructor inside the private area of the class definition. So here's the class definition. And inside of the private area, you have both the constructor and the destructor. Okay? This means that you cannot instantiate an object of type game ever. The only way you can do this is if you go through the instance function. The instance function instantiates an object of type game and returns a reference to that instance. And because both the instance function as well as the actual game instance inside of it are static, it's always going to return back an instance of the game itself, which means you're never going to have more than one game. I'm not going to point to more than one of them. There's different ways to write singletons. This is one way. The other way to write a singleton is a little bit more complex. However, it's a little bit less thread safe. And I'll show you that when we look at another singleton. Inside managers, there's something called font manager. And if we look at font manager.h, we can see another instance of a different type of singleton. Right? So here's a singleton, but in this case, font manager returns a pointer, not a reference. And in this case, we have a static font manager pointer called s_p instance. By the way, the naming convention we're using is s is static, underscore means private, p is pointer. So a static private pointer called instance. The variable name is called instance. And what happens is that my static function instance checks to see if the variable is not null pointer. If it's not null pointer, then it instantiates an object of type font manager and returns it back out. If it is null pointer. If it's not null pointer, it just returns the instance that already exists. One thing to note with this kind of structure, you also need somewhere to set s_p instance as null pointer. And we normally do that in the font manager.cpp file at the top, right? So as you can see, this structure, it's still a singleton. It works very similar to the other structure, right? Which in game.h looks like this, but you can see how much more simplified this is. And it does the same thing. In fact, in this way, this is better than this. But we have a bit of a bug, and I'm going to fix it for Font Manager going forward. So that's a singleton. The singleton, if you want to, is a design pattern. It's one of the 23 design patterns that was created by the Gang of Four in the 90s. They wrote a book, right? I want to talk about that book for a second. So if I look at the design patterns, by the Gang of Four. If you look that up, this was a book that was written in the 90s, right? 1994. And it talked about object-oriented design patterns. And one of the 23 design patterns is the Singleton design pattern, okay? And there's different ones: creational, structural, and behavior. If you look at the creational design patterns, you can see that Singleton is one of the creational design patterns that is out there, okay? Again, we'll go more into design patterns later on in the program at George Brown College, most likely in third year. Okay, but I wanted to introduce singletons because we're using them throughout the entire semester. Again, what it says is it restricts the object creation for a class to only one instance. And why would we want to do that? Well, the great thing about that is that we only ever need one game instance, right? We never need more than one game, right? At least when we're running this code. We never need more than one collision manager. We never need more than one event manager. We never need more than one font manager, stand manager, texture manager, or any of these other ones. Notice that I made these managers, but these are just singletons because these aren't managers. I don't have a renderer manager or a game manager, or although I could. And this Am Gui Window frame is not really a window frame manager, but then I could make that. If I really wanted to, I could make these together. I've just named these the way they are. All right, so these are all singletons. These ones, as well as all of these ones. Okay, so that's the way this is structured. So this is a singleton. And remember, whenever we go through to access functions that are contained in a singleton class, you have to go through the static instance function. Instance is just a name, a convention. You can call this whatever you like. As an example, I've called it instance because it makes sense. You go to game instance, and then from there, you go to one of the files you want. As an example, in main.cpp, we set up the frame rate at 60 frames per second. Our delay time then is 1,000 milliseconds, so that's 1 second, divided by the frame rate that we want, which works out to be 16.66 milliseconds. 66666. Non-terminating, non-repeating, repeating. We have our frame start and our frame time and the number of frames. I count those things. And then what I do is I use, hey, the game, there's my singleton. Whenever you see instance for you from now on, from today on, I want you to think about, this identifies that whatever the structure is, the class is, it must be a singleton in the way we're using it. So we're saying, hey, game, I want you to go through the gateway that is your instance and get me the init function. Cool. As soon as I do that, I instantiate game for the first time and the only time. Here is where I specify what the Windows name is going to be, Sdl Engine version 0.25. So when I run it, there it is. Okay. Actually, this should actually read Sdl_engine, which is what we did. And then the X and Y coordinates, as well as the width and the height of the screen, and if it is full screen or not. I warn you, if you make it full screen, it'll make it change your screen resolution to the resolution, which is 800 by 600. If you want to make this full screen, make sure that this resolution matches the aspect ratio of your screen, or else it'll be weird. Okay, my screen is 1920 by 1080. If I did that, if I change this to 1920 by 1080, it's like I'm getting full screen anyway. So example, if I change this and if I run it, there it is. You can see that I haven't centered things on my screen, right? But my screen size is 1920 by 1080, right? And just like before, what I can do is, if I make this true, now this is where things mess up. So I'm going to warn you, this may mess up my recording, but I'll try it anyway, because what the heck. So I'll make it true, make screen, and there it is, right? If I press the back character, what it is, I'm going to have my little Am Gui Window on the side, and my screen has disappeared, which is kind of way down here. So that's what full screen does, just to warn you. Let's go back to 800 by 600. And let's change this to false. One thing I've also done is I've also created a config file. Config file. So the way you access the config file, and when I say config, so config.h, let's go to Solution Explorer and let's take a look at core config.h. Here's config.h. It has screen width and screen height. So let's suppose instead of me changing my screen width, my screen height manually like I just did, I can just take screen width and screen height here and only change it in one place. And then what it'll do for me is it'll change it everywhere. Right? So let's do that instead. So config screen width and config. Let's see if this still works. Screen height. Okay. And then when I run it, again, it should work exactly as it did before. There we go. So that's what config does. A config is just a file that I'm using. So again, if I go back to my Solution Explorer, my config file is just a static class, a container class that contains some constants. I also have, in addition to that, some other files that I recommend you do not touch. What these are basically little functions. They're little deleter functions that I use for my shared pointers. I'm using shared pointers here to save memory and to have managed pointers instead of using raw pointers. So here I'm using a shared pointer. I highly recommend you don't touch these things. In the future, I'm going to move these files out of here and put them somewhere else where it's not in the config, but something else. Maybe I'll call it shared.h. All right, so that is our config.h, and that is so far our main. In our main, we call our game instance and we set up the window. Then inside of our main, we have our while loop. This while loop is the main game loop for the entire program. In other words, the main game loop runs here. The main game loop looks at the game instance and checks to see if it's running. This is a Boolean. If it's running, then it keeps looping. We capture Sdl get ticks, captures the number of ticks in milliseconds from the time that Sdl has started, right? And saves them in frame start. And then I call 3 functions. These are lifecycle functions: handle events, update, and render. And these 3 functions are separate inside of the game instance. The reason why they're separate is I could assign them to different threads if I wanted to have a multi-threaded application. Right now, I don't have that, so they're all just separate functions. What I'm doing here is I'm frame limiting my while loop. And the reason why I'm frame limiting my while loop is because the while loop, if I didn't frame limit it, right, and by the way, the way I'm frame limiting is I'm saying, look, here's my frame time. I'll take my current time, subtract it from my frame start, and that's my current frame time, whatever that is, in milliseconds. If my frame time is less than my delay time somehow, so it's running faster than I want, slow it down, please, Sdl. Why? Because if I didn't frame limit it, and if I just ran my while loop as fast as possible, well, guess what? My system might run slower or faster than your system. Your system might run slower or faster than my system. So we're going to get inconsistent gameplay, right, between sessions, which is a very bad thing. I also capture delta time, And what delta time normally is, I take my my number of get ticks, I subtract frame start and divide it by 1000, and I return that back. I save it in the game instance. So if you want to multiply something that's running, some kind of input by delta time, you can do that. And the same thing goes with frames. I also do frame counting for you. So I set the number of frames from the beginning that we started running our structure. I save the number of frames inside of the game itself as by using set frames. So you can always get delta time and get frames from the game. Just call the game instance and you can get delta time. And we use delta time and set frames for different functions. From animation, I use set frames or get frames from if I want to make frame-based animation, to delta time if I want to move something in a smooth way across the screen without spamming the input. Okay, that's what this does. Pretty cool. And that is your main .cpp. Let's move on to game. Game.h, again, is our main game, our main construct. This is where all the fun happens, right? Basically, through this is kind of our single point of contact for all the other functions that run outside, or all the other classes. Notice that I'm including core libraries like IOStream and string and vector, as well as sceneState.h. Let's look at sceneState.h, and what is that? I've also created a bunch of enumerations for you, or enums. SceneState is just one of the enums I've created for you. An enum, or enumeration, is a friendly name for an integer, for the most part. Example, isn't it easier for us to say start scene instead of 0? 0 doesn't make any sense, but start scene does. And so does play scene instead of 1, right? At the end of the day, on the back end, C++ doesn't care how you use integers. For you, it's more human readable if you use an enumeration as opposed to a number. So that's why I use scene states. So if that's true, so I include scenestate.h. I also include collision manager.h. We're going to go over that later on. I also include all the 3 scene types: start scene, place scene, and end scene. Okay, those are my 3 scenes. I'm going to go into scenes in a bit. And config.h. And config.h, remember, is I'm using that just like I did inside of my main scene. One thing also to note is at the top, this pragma once. Remember what this is. This is a guard, right? This stuff up here. The pragma once is Microsoft specific, so MSVC specific. That means that if you include pragma once in a MSVC or Visual Studio C++, Microsoft's compiler knows that this has already been called. You only want to include this once, is what this means. Okay? However, if I want to port my files over to Linux, or if I want to port my files over to Mac, then I need to use another guard, which is if not defined. This is a directive, a compiler directive. If I not define this macro game, then I define game for the first time, right? If it's not defined. And then I end if. If I ever try and include this again, it says, well, it is defined, so don't include it again. Only if it's not defined, define. That's what this means. All right, cool. So I include some libraries, and then I have a public area, which is the instance. I have 2 init functions. One of them is a default init function, and the other one is an overloaded init function that includes the title, x, y coordinates, width, height, and full screen, which you already saw in the main.cpp file. Then there is the lifecycle functions, which are render, update, handle events, clean, start, and quit. And these functions you're going to see a lot in the scenes. Okay? If you want to get the mouse position, the number of frames from the beginning of the time we started our code, or delta time, or if you want to change a scene state, you go through the game instance. If ever you need the mouse position, just go through the game instance and it'll return it for you. okay? And that's what the game.h is for the most part. Game.cpp, let's go into that a bit as well. I know this is very detailed, and I know you want to go. Faster than this. Some of you, bear with me. Trust me, if I go faster than this, there's a lot of detail that you'll lose. You'll have questions from me later. Nahar asks, the guard would be used for every header file, right? Yes, every header file should have a guard like that. Let's go into next thing, which is game.cpp. In game.cpp, right, as an example, we don't need this anymore. That was the old stuff, a little bit of a remnant. We include game.h, algorithm, IO manipulation, as well as GLM. Talk about GLM in a second. Our renderer and our event manager. Remember that the renderer is a singleton, and so is the event manager. So whenever I call game.cpp, here is the constructor function. The constructor function also instantiates a random number seed, and it only happens once. There are two init functions. One of them is I set up my m_b running. Remember what m underscore is? Member variable, private, that's the underscore. B for Boolean, running is the name of the identifier. So a private member variable that's a Boolean called running, we set it to true by default. So the game is running whenever we instantiate the game instance for the first time. Then what we do is I have an overload, and the overload allows us to create an Sdl window. And notice here I'm using make resource from the config file that I talked about earlier. Make resource creates a shared pointer out of my Sdl create window function that's built into the Sdl framework. Okay. The reason why I want to make it a shared pointer again is for management purposes and for memory management in general. I check to see if it's not null. Somehow I'm not able to create a window. And then I create a renderer the same way here. When I create a renderer, I save it inside of the renderer instance. And then I check to see if I can get the render. If I can, then I've got the renderer successfully. I set the render draw color to white by default. And then I call the Am Gui Window frame class, and I initialize its instance. So that's why I have two windows. The first window I create here for my main game window, and the second window I create for my Am Gui window for debugging purposes. And I'm using my own custom class called Am Gui Window frame. Again, you don't have to touch this Am Gui Window frame class. It's been created for you, and we're going to update it together. I also instantiate my true type fonts, and then finally, I call the start function. The start function sets my current scene state to no scene, which works out to be -1. And then I call the change scene state function inside the game, which changed the scene state to whatever scene state I set it to. For now, I set it to the first scene state, which is start scene. How does this work? If I right-click and go to definition, you can see that I'm going to go here to change scene state. By the way, I need to pause here for a second. And I need to pause here because you might be seeing something different on my side than you do on your version of Visual Studio 2019. Notice on the left, I have these marks. If I right-click, right, or if I click on these marks, I have these things here. You may not have these things at all. And the reason why is because I'm using an extension for Visual Studio called ReSharper. Here's ReSharper. You can have access to ReSharper, which is an awesome extension. It does refactoring and all kinds of other things free. But where it exists, if we look at ReSharper, is through, JetBrains. JetBrains is the company that makes ReSharper. It's not free, okay? Definitely not free. But what ReSharper does is it gives you things like it can generate code for you. It can do a lot of amazing refactoring for you and great tooling to make your code adventures easier when we're coding for AI in class. All right. So I highly recommend you get yourself a copy of ReSharper C++, but it's not free. So what do? You can apply as a student to get access to all of JetBrains applications for free. And I've given you that link here in my content. So if you go to Labs, and if you go to Lab 1, you can see that there is a JetBrains educational account that you can download. If you click on this link, it'll take you here, and you can apply for a free educational license to use JetBrains for teachers and students. So please do this as soon as possible when you install Visual Studio 2019, if you haven't done it already. It's an awesome tool, and I'm going to be using it throughout the entire semester. And so is Alex. All right, this is great. So let's get back to Visual Studio 2019. So again, I've got my change scene state. So what is change scene state? I passed in start scene. Remember, it's just an integer, right? That's really what it is. And then I do this. I say, well, look, if my new scene state is different than my current one, what does that mean? That means I'm changing things. I'm changing my scene state. If my new scene state is not different than my current one, then don't do anything. Skip all this whole thing. That's what this if statement is. Really, this first if statement is a guard to make sure that I don't try and change scene state, as an example, if I don't need to, right? And then I do this. Let's check to see if my current scene state is not equal to no scene. This means that if it's equal to no scene, right, I'm going to skip this because I don't want to clean up something that doesn't need cleaning up. If it's not equal to no scene, let's say I'm switching from my start scene to my play scene, then I need to do some cleanup in order for me to remove fonts and textures. Otherwise, my memory is going to go up, 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 up. It's going to keep going up every time I add more textures and more fonts. Then I set my current scene state to null pointer, and then in my current scene state here, I assign it to new state. I pass it through a switch case, and I say, this is kind of like a state machine. And I say, well, okay, if my current scene state is start scene, then I want to instantiate an object of new start scene. Wait, what? An object of new start scene? What are scenes anyway? Well, going back to this, scenes, right, are another core construct. If I go back to scene.h, scene.h is inheriting from, extends, game object. What? What's game object? Let's take a look. Let's press F12. By clicking on game object and pressing F12, it'll go to the definition of game object. All right, what is game object? Game object is, remember there's three types of game object, guys and girls, right? The first type of game object is an object that updates but does not draw. Another type of game object is an object that draws but doesn't update. And another type of game object is a game object that draws and updates. This type of game object I've defined here is a game object that only updates, right? Well, actually, you can do both drawing and update, but I can define a regular game object as an example that draws and doesn't, or updates and doesn't draw, as an example by using this game object. I have other ones. And the other one would be display object. Display object is a game object that, well, draws, and it's something that I want to include in my scenes. So remember how inheritance works. I'm just going to bring up our little drawing again. Just as a reminder. So when I have a class, here's a class, and this is my game object superclass, and this is an abstract superclass. Remember how we make abstract classes, right? it's an abstract class is like a blueprint for other classes. And if I go back to my code, and if I go back to GameObject.h, the reason why GameObject is a superclass that's abstract is because it's got a virtual destructor as well as pure virtual functions. At least one pure virtual function is required to make this class an abstract class, right? An abstract class, you cannot instantiate an object of an abstract class. You can only use that class as a blueprint for other classes. But remember how object-oriented programming works. When I have a parent class, by the way, they're called parent class or a base class or a superclass, whatever. These are all the same things. Parent, base, and super, right? Oops. They all mean the same things, right? Whenever we have a child class or a derived class, right, as an example, anytime we have that, then that class that when we inherit from the parent class, it's always going to be bigger or fatter than the parent. I always want you to remember that. So child classes are just bigger and fatter than the parent classes. And so this is why inheritance is not really looked upon fondly from game developers. Why? Because if I have all of my classes, and let's take a look at this one now. So this is GameObject, and underneath GameObject, maybe I have a scene. So here's my scene class, right, which inherits from my GameObject superclass. It's also an abstract superclass because it can be both a child class, right? It's a child of the GameObject, but it's also a parent of all the other scenes. That's how it can work in the hierarchy, right? So it's an abstract superclass. That means scene also needs to be overridden. And how many scenes do we have? We have right now 3 scenes that I've defined as concrete classes. So I have 1, 2, 3 scenes. And I'm just going to make them small here, but they're actually bigger than the scene class. The first one is the start scene, right? So this is a class, and this is a concrete class. That's also a final class. I've made it final so that you cannot inherit from start. You're not going to make another subclass of the start superclass, right? By the way, those are nice names for child classes. So remember, the different names are, you could have child class, derived class, right? So child class, derived class, right? These are all the same. They mean the same thing as, as an example, as each other. Child, derived, right? Or subclass. So child, derived, subclasses, they're all the same as, they all mean the same things for the most part, okay? Concrete class is the one that you can instantiate. Abstract classes, you cannot instantiate new objects. So we have start. I'm just talking about the structure of our application right now. We have a couple more, right? We have play. And we have end. Those are our 3 scenes. Each of them is a class, right? And they derive from the scene class, which derives from the GameObject class. Okay, I'm just letting you know the structure. That's how it works. Back to this. All game objects have a draw, update, and clean function. And they also have a transform, and a rigid body. If I look at the transform and the rigid body, there are other components. So this is using something called composition, not inheritance. What we're doing here when we create a superclass is we create an inheritance chain or hierarchy. What I'm doing here when I'm using structures or classes that I've created, I'm using composition. So here in the component, there's two components I've made. One is a transform. The transform uses GLM. GLM is a library that I've included in our structure. And I'm just going to put this up there for you. The library that we've included for GLM is this library right here. So GLM, see if I can get to that. Yep. Stands for OpenGL Mathematics. That's what it is, GL Mathematics or GLM, right? What it really is a whole library of mathematical functions that you can use. It's pretty awesome. And from an API documentations perspective, right, if I wanted to look at all the modules, these are all the modules that are included, right? GTC, different kinds of extensions, right? There's normal as well as range for vectors and matrices. Any kind of vector or matrix transformation, you can use the GLM library to do those things, as opposed to make our own vector and matrix structures. Why would I do that if I have a beautiful library like GLM that does it all for me, right? And so that's why I've done it. I don't want to make my own library when something like this already exists. And by the way, when you guys do your OpenGL course in the first semester of second year, right, then you are going to use the GLM library as well. Not just, as an example here in my little code, which is pretty awesome. That means I'm getting you used to it early. All right, let's go back. So I'm using GLM vectors. There's vector 2, vector 3, vector 4. A vector 2 is x and y coordinates. A vector 3 is x, y, and z coordinates. And you can also turn on some awesome stuff called swizzling, where I want to return both x and y at the same time, as opposed to, or if I have vector 3, I can say I want x and z returned. So .xz, if I turn swizzling on. For now, we're not going to use swizzling. We don't need that kind of stuff. We're just going to use vector 2s for position, rotation, and scale. So that's the transform struct. Okay. I also have a rigid body component that includes mass, velocity, acceleration, and if the object is colliding or not. We're going to use the rigid body component more next semester when we hit physics together. Okay. Because we're going to be using this structure, this framework for physics as well. Cool, so we've got our rigid body and we have our transform, and that's part of our game object superclass. So that means all game objects, including scenes and including display objects, have the transform and rigid body components. Wait, why scene? Why would I want my scenes to have a transform and rigid body component? Well, what if I wanted to do screen shake? I could do that. What if I wanted to transition a scene or do a wipe or something like that? Or I wanted to spin the whole screen around. I could do that too. If I wanted to scale the whole screen, I can probably do that too, if they're all game objects. All right, so that is scene. Scene.h is a superclass that includes the draw, update, clean, handle events, and start functions, just like the GameObject.h does. A couple things with GameObject.h that you should also know. It also does, I can also enable and disable my game objects as well as make them visible or invisible. There's a difference. Enabled means they're there in the scene and they're visible. Invisible, set visible or not, they're enabled, but I make them not visible. They don't draw. So I can create objects that are there. They don't render, but they're physically in the scene. So if I want something, if you want to collide with something invisible, an invisible wall or some other kind of structure, that's why I've set these things up like this. Or if I want to make things disappear and reappear, I can simply make them visible or invisible. So again, these are all things that I've included. Nahar asks, is that why they're virtual in scene.h? Yes, because all of these functions get overridden, and so too in they're inherited from GameObject, but they also get overridden in the scene subclasses or child classes. Okay. Scene is special in that it has a couple of additional functions. One of them is add child. Right? What add child does is it adds a display object. So all objects that are added to the scene must be a display object. So for example, I have some game objects like the player. Player is a sprite. A sprite is a specialized display object. And if I go there, if I go to a core, and if I go to sprite, sprite is a display object, and display object is a game object, right? Now think about that inheritance chain. I've got game object, display object inherits from that, right? And then I've got sprite, which inherits from display object, and I might have something else that inherits from that, right? And so why is this bad? Well, because it makes game objects very fat. And from a performance perspective, it's not great from a performance perspective at all. So hopefully you got that. So not great from a performance perspective. So, okay, that's great. So we've got this structure, and scene then depends on display objects. So here's my scene. I can add a display object. I can remove a display object. I can update something called a display list, and I can also draw the display list. What is a display list? It is a vector of display object pointers, right? So what I can do is when I update my display list, right, I loop through each of the objects in the scene, the display objects, and I check to see if they're visible. And if they're enabled, as an example, I update them. For my draw display object, I do both things. I make sure that the object, as an example, is both enabled and visible. Both those two things must be correct in order for me to update my display object and draw it. Okay? So that is how the display list works. Now this is the scene superclass. That means all other scenes, that means the start scene, the play scene, and the end scene all have the same capabilities as the scene superclass. Okay? That means they can all have a display list. I can add child, I can remove child, all that kind of stuff. All right. Let's go back to scene.h. So that is your scene.h. Okay. Let's look at display object. Display object is also a game object, but it's different than scene, right? Scene has different specialization. Display object has another specialization. Display object allows me to set the parent class, right? And it also allows me to set the layer, the drawing layer of my object. By default, whenever we add an object, right? A display object, it's going to add or layer in the way that I add it in. So if I add my spaceship first, and then on top of that I add a planet, the planet is going to appear as if it's on top of the spaceship. But what if I want to make my spaceship appear on top of the planet? I can change the set layer index here. Okay? And sometimes I can have two objects in the same layer, but I want to change the layer order. I can do that too. And I've done that here in my display object. All right, this is fantastic. This allows us to print things out with my display object, right? That's what it does. And display objects are used in scenes, right? Because I add child, my display object to the scene, and I can remove child if I want to get rid of it. Okay. One thing to note is I don't ever have to destroy an object. I can reuse it. Again, going back to what we talked about before, we can use a design pattern called an object pool. For example, if I want to shoot bullets at something, right, as an example, I'm not going to create new bullets and then destroy them when they leave the scene. That's not efficient. It's better to use an object pool. And that is a new design pattern. Again, very similar. It's an optimization pattern that we can use from the Gang of Four, right? As almost like a container of bullets that I want to use. Okay, cool. I know this is not the most exciting stuff, but I got to run through this with you guys, because if I don't run through this with you, you're going to go, wait, and how do I do that again? And what do I do? And what's this big mess you've given us, Tom? It's not a big mess. It's organized, but you have to understand the application, the way the API works. All right. So that is, in a nutshell, how our scenes are structured. Let's take a look at the workhorse of everything, which is our scenes themselves. If I look at the start scene, then start scene is final. Final is a leaf class, or something that you cannot instantiate. It prevents you from something that you can inherit from. You can instantiate objects of type start scene, but you cannot inherit from them. So why do I do this? Because each scene is unique, right? I have a start label and an instructions label and a spaceship, as well as a start button in the scene. Each of these things is a class, right? And all I'm doing is I'm instantiating objects of this class. In the start scene.cpp, then, when I go to the start function, I'm using the add child method to add the start label to the scene. First, I configure the start label, and then I add it to the scene. Then I configure and instantiate the instructions label and add that to the scene. And then I instantiate the ship and add that to the scene. When I'm doing an update, I just update the display list or draw the display list. And anything that's been added, I add it to the scene, does that for me. Okay, I've gone through a lot of stuff. Let's get to the lab piece now so that you can complete your lab finally. So this is kind of like a tour of Sdl Engine for you. And I haven't covered everything. We're going to cover more as we go. All right, let's do it. So what I want you to do now is, if you run the code again, right, here's the actual thing I'd like you to change. So I'm going to run the code. And when we do, we're going to get to our start scene for a second. When we get to our start scene, when we click the button, it's going to take us to our play scene. What I want to do is I want to wipe away this label, this and this button, as well as this plane. Let's do that first. Let's get rid of these things. Let's remove them. Easy way to do that is to double click on the playscene.h. And let's go through and remove those things. And you can see in the private section here, I've included my plane sprite. Let's get rid of it. As well as my UI items. Let's get rid of all of these. When I do that and save, then if I go to my playscene.cpp, yes, you will do that. Nihara, I'm always going to give you the assignment template. That's going to be for your assignments and your labs. I'm not going to ask you to do things from scratch. There's just no way. By the way, guys, just as an aside, in earlier iterations of this course, we built everything from scratch every time. So can you imagine spending all this time every semester building this over and over again? It doesn't make sense. And that's why we created Sdl Engine. It's much easier this way. Easier from an understanding perspective, because imagine if you were going to try and learn about AI plus our construct here, this crazy structure. All right, so yeah, let's look at all these errors. These errors have been generated here on the right. And by the way, this little scroll bar, if you right-click onto it and go to scroll bar options, you can change how wide it is. Right now it's medium. You can make it narrow, or you can just turn it off if you don't like it. You can also remove the vertical scroll bar altogether, just for a vertical scroll bar, so you don't even see anything at all, right? I can put it back. By the way, you can also do other things here. Show annotations over the scroll bar, show changes, marks, errors, caret position. You can undo all those things if I want to. And you can see that I've removed a lot, right? And you can always put them back. So you can see a sense, you can get a sense of when I hover over, I can look at the errors that exist in the code, and I can go right to that, click right there, and I can change it. Well, there is no plain sprite, so let's get rid of this. And there is no back button. All this UI stuff, I got rid of it all. So let's get rid of it. Another day we'll go over UI. Right? And now we have everything we need. Just the player and the Am Gui window frame that I made, which gives us a separate window for my Am Gui functions. And it points to this GUI function right here, which is right underneath it. Okay, that's what it does. It points to this thing. My Am Gui function creates a button. Remember, Am Gui has a bunch of widgets you can create, and as well as a slider 3. We don't need a slider 3. We only need a slider float 2. We're going to get back to this. Let's run to see what it does right now for us. And we just got rid of all those things. They made our start function very, very simple. Let's run it. Okay. And when we do that, you're going to see that when we click on the button, it has our little lonely guy right now. That's what he does. If I bring up my my Am Gui window, what I want to do is when I move these things around, I want him to move. So let's get that happening. Down inside of my GUI function, again, this is the lab part. I don't need a button, so let's get rid of it. And the separator. Let's get rid of my button and my separator. Let's get that gone. I'm left with a static float 3. Let's rename this to float 2. And also, let's change this from 3, an array of 3 size, to array of 2 size. We don't need 3 initializers, only 2. I'm going to call this float 2. It's going to start at 0. That's the slider. It's going to be the position. Let's rename this to position. And it's going to go from 0. If I want to make it negative, I can. Let's say negative 800 or something like that. But that doesn't make any sense. To 800. Okay? From 0 to 800 means we can go off screen if we want on the height of the screen. We don't need all of these. These are going to print out, and these are going to say float 2. So this is what's going to print out now, right? X and Y coordinates. We're going to set the initial state of this to 400 and 300. Okay, 400 and 300. And if I haven't changed the player yet, my window title goes here. Let's change this window title to Lab 1B. That's for you guys. And if I run this thing now, this is my UI function. If I run this thing now, you're going to see that when I go to my play scene, and if I press backtick to bring up my window, I'm having this little thing come up. Notice that it's way over here, and I can't move it. I have a bit of a bug, and I'll show you the bug. I've stopped moving it for this demo, but you can make it move again by removing this thing right here. Again, this is on my line 134. and it's inside of the Am Gui begin function. I'm just going to go over here and remove the window flags. I'll fix it. I just haven't had a chance to do it today. When I take that away, and if I run it again, now I'm able to move this window, but I get a bit of trails happening. And this is why I want to fix this. I get a bit of remnants. Don't worry, I'll fix it. It's just I need another clear somewhere. But notice here how I have, if I bring up my console window, right? Here's my console window. If I change these things around, those values change. But I also have this one, which I don't want anything to do with this one. I have a Z value. Okay, let's fix that. So we don't need a slider float 3, we only need a slider float 2. If I run it again, you can see that that is a widget that exists in Am Gui, right? And now you can see that it says position, and this is a slider float 2. What I want to do is when I move this or this, I want this guy to move. And the way to do that is we can call up the object. Remember, it's called M_P player. Member variable, private, pointer. The identifier name is player. It's of type new player, so I've allocated memory on the heap and stored a reference to it as a pointer inside of this identifier. I added this object onto the scene as a display object. And every frame, I'm going to update the display list, which this child is a part of. Okay? So therefore, all I need is M_P player to modify. Going down here, I can say M_P player. And what I want is, I want to get transform. Remember the transform idea? Dot position. So position is, remember, part of the struct, the transform struct? And I want to set the position of the player to a new GLM vec2 object, which is going to be float2 0 and float2 1. Why is that? Float2 0 is coming from this static float. It's called float2. It could be position. We could rename this to position. Let's do that to make it more user-friendly or readable, right? So we're going to go refactor, rename. We can call this position. Right? So a static position, that makes sense, right? Position is an array of 2 floats, right? And the first float, or the X value, is going to be part of a new vec2. And the second float, which is the Y value, is going to be part of the vec2. And now what we want to do, this is going to change the position of the player every time we move the slider. Let's see if this works. So go to my placing, bring up my Am Gui, and if I did it right, change the position of the player on the screen. And my friends, that is your lab for today in terms of the stuff. For Nihar says, would we need float 3 if we were dealing with 3D game objects? Yes, you would, if you really wanted to move them in 3D space like that. I'm just giving you an example of how you could change the position of an object on a 2D screen. But yes, you can make any changes you want using this window. Cool. So for snapshots, for the snapshots for the lab, definitely what I would do is this. The first snapshot is, hey, can you get your game engine to go? Can I see that you're running version 0.25? I'm serious. I want to know that you can make things go. Next, when you run this thing, I want you to take a snapshot of this, right? So at 400 and 300. And then take another snapshot with some other value. All right? This snapshot right here, so I can see this. Those are your 3 snapshots for today. something like that. Okay, I don't need your code, just this stuff. I want to see that it's working. Okay, and once we have that, now we need to put this up on GitHub. This is the next part, right? So the easiest way to do this, and I'm just going to close all of my tabs on the top here, right? I'm going to right click and I'm going to close all tabs. And I want to concentrate now on the GitHub piece. Again, this is being recorded for you guys. You can always refer to this again. The first thing that you want to do is, let's go to where it says Team Explorer here. If you don't have Team Explorer on the bottom right of on the sidebar, you can always get it. I can go to Window, if I go to View, and if I go to Team Explorer, it'll pop up. Like so. Okay? So I can always get to Team Explorer if I want. But this thing has never been added to source control. Down here, you can see that on the bottom part of your screen, I guess I'm blocking it a little bit, right? I'm blocking a little bit, but here, I'll move my whole body so you can see it. Down here, it says add to source control. Over here. So you can do it that way, or, right, instead of doing it down there, what you can do is you can go to your solution, and if I right-click on my solution, I should see Create Git Repository up here. If I click Create Git Repository, this is new for Visual Studio 2019. They've updated Git Access. It's part of Visual Studio 2019. If you don't have this option, you need to update Visual Studio 2019 to the latest version. If I click on Create Repository, you're going to see this. And this is pretty cool, right? You can see that my account has been added, right? You can see that this is the owner. I can look at any of the organizations I've created, and I want to look at, of course, George Brown. I don't want my repository name online to be template. I would rather that it's called the right thing. So it's going to be GAME3001 in the summer 2021 semester, and it is Lab 1B, which is you. For you guys, you should mark it private. For me, I'm going to mark it public or unmark this. And then when I'm ready, I'm going to create kind of click on this button, which is create and push. Let's do that. And if you've configured your code correctly, it's going to push this up to GitHub. Let's see what else we can do, because under our Team Explorer, we can go to Home, and notice I have Git Changes and Git Repository, right? I also have something called Settings. I want you to go to Settings, please. And it says there's no available settings for Lab 1, right? But sometimes what you want to do is, and they've changed GitHub recently, I have to admit. So these are all changed. But sometimes what will happen is you have to configure your information, who you are, and all that kind of stuff. You do it for the first time when you do that add to Git thing that I just did, right? And when you do it one time, it's done forever. It remembers your credentials. Notice down here now, I have the Git repository link. Think about what this is. This is the remote that I was talking about before. GitHub.com/George Brown College /Game3001 M2021 Lab 1B. That's my repo, and I've pushed it up. Let's take a look online and see what that looks like. So again, I'm going to go up online. I'm going to go to George Brown College, and you can see now that I have Lab 1B. There it is, Lab 1B. I'm going to click on Lab 1B, and you can see that I have one commit by me. I added my project files through Microsoft 2 minutes ago. Okay. this is the link that I want you to give me for your lab, this link right here, okay? Don't give me this link. Sometimes people, for whatever reason, give me the link for their account. I don't want your link for your account. I also don't want one repo for all of your labs. Don't give me that. I want one repo, one lab, okay? So I want you to make new labs. Every time we do a repo, I want you to make a new lab. Every time we do a new lab, a new repo, please. It's easier to mark, and it's easier for me to keep track of. Okay, so that is pretty cool, right? That is our Lab 1B. I'm going to post this solution for you guys on Blackboard. So on Blackboard, I'm going to make a new web link, and we're going to call this Lab 1 Final, right? The starter for Lab 1 was really the framework this week. But next week, I'm going to have a Lab 2 starter. And guess what it's going to be? Our Lab 1 Final is going to be our Lab 2 starter. I'm always going to base the previous lab or the new lab on the previous lab. Okay? So now this is our Lab 1 Final. I'm going to put it above this little recording I'm making right now. So that's the first thing. You need to get your GitHub link. The second thing is people always ask me when you do a zip file, what are the garbage files? If I look at Lab 1B, here's Lab 1B. Notice there's a hidden .git folder here. And there's also a hidden .vs folder. The hidden .git folder is for your GitHub repository. Don't delete this. The hidden .vs folder is where you can clean up your files. First, let's shut down Visual Studio before you zip it up. Why? It has a lot of files that are open when it's open, and so you wouldn't want to zip it while it's open. Second, you want to go into your .vs folder, into your template, into v16, and get rid of or delete browse.vc.db. This is a database file that is not required. Right-click and delete. And this IPCH, these IPCH files, right-click and delete. Okay, cool. And if I go back, now I've got rid of most of my garbage files. There's other ones, but they're not as big as that one. Remember, you can always hover over to see the size of your files. Okay? 10 megs for the includes. Libraries that are 1 meg. The SRC folder that's 114K for all of our code. Template, that's 20 megs. And x64, right? There's nothing in there. Let's go into template and see if there's anything else we can get rid of. And the answer is you can. If you go into intermediate, debug, these are all our intermediate files, and you'll probably get rid of all these too. Right? Let's see if this is true. And same thing with x64. There's nothing in there, right? So we can probably get rid of that. So get rid of this. And all of our intermediate files. What if we got rid of this? Would things still work? Now, if I go back to my folder and I look at this one, its total size is 35 megs. What about the one I did previously? It's 54 megs. I got rid of more files here than I did before. What if I want to run it again? Well, is it going to destroy anything? Am I going to be in trouble? No, it won't, because what's going to happen is Visual Studio is going to, when I run this file, when I build and run, what it's going to do is it's going to regenerate all of those files again, right? Let's take a look. Let's see if I'm right. Okay. It's going to regenerate these files again. And when it regenerates the files, it's going to create all kinds of a big database of stuff for debugging purposes and all this kind of stuff. Look, here we are again. It's running fine, even with my deletions, right? How big is this file now without me minimizing the garbage files? Let's go back up one and see how big it is if I hover over. Guys, this is 48 megs. It's not that big, right? In fact, sometimes it's smaller than the previous one. 54 megs. But what it did was, in template, it regenerated the intermediate files. However, every time I run a debug, it'll generate more and more debugging information. So your files get bloated and more bloated and more bloated. So the more time you work on a project, you might have like 400 megs of files, especially if you have multiple scenes and they're quite complex with multiple objects running around. Your build can be quite large. And that's why you need to remove those files. Okay? Again, let's take a look one more time at what I can remove. In the VS folder, if I go to V16, look, it generated the vc.db folder, db file again for 47 megs. Just get rid of it, delete. And go in and delete that stuff right here. So in intermediate files, delete that too. Delete, right? And once you've done that, once you've deleted those two things, right? And if I go back out, my lab 1B is now sitting at 31 megs. Let's zip it. And again, I recommend using 7-zip. I've already posted 7-zip on our content in external links. Please download and install 7-zip because 7-zip is the way to go. I will not accept RAR files from WinRAR or zip files from WinRAR. Please don't do that. Please use 7-zip. You're going to have no problem doing that. And do not use the built-in compression program that's built into Windows 10. It does not always work properly. Okay? 7-zip is the way to go. All right, let's go back. So I want to zip it up. How do I do it now? Well, I can right-click, and when I do, because I have 7-zip, I have a context-sensitive menu, and I can add to lab1b.zip. It zips it up. Then, when I look at it, lab1b.zip is 19.5 megs. That is a reasonable size. 19 megs. Not 400 megs, and maybe not even 54 megs. Okay? You're going to upload this, and you're going to give me the link that I showed you earlier, which is this link up here, and 3 screenshots that are separate. Please do not bury your screenshots and your GitHub link inside of your zip archive. That is not acceptable. Why? Because that means I have to unzip 54 megabytes or something like that for each of you. That would be a bad thing. How do you do screenshots? Well, Control and print screen is one way, but I like to use Sharex. Sharex is a pretty cool, free, open source screen capture. Well, it does captures. It does a bunch of other stuff too, but it's a great tool for capturing the screen, right? So again, if I was to run my code, let's go back to run my code here. And here's lab1b. And if I run it, and let's run the code again, it's going to regenerate those intermediate files again. Let's do that. I know I'm running out of time, guys. I need one more minute just to show you this, and then we're done. And the reason for this is I want to make sure that you guys are all successful this semester on how to do all this stuff. So I want to do 3 screen caps, and notice that I have my Sharex file right here. There's Sharex, right? Sharex is pretty cool what you can do. So take a look. So I want to capture this, I said, right? So I go to Sharex, and when I do, I can select parts of my screen, right? Like let's say this window, and I can capture it. And then what I can do is you can configure Sharex so it saves your files if you want, or you can open it up in your favorite program or whatever. Okay, so that's how you share. So let's say, for example, I want to put it in something like Word, right? So here's Word. Let's just copy the file. There's my my file from Sharex, right? You can see that that is my screenshot, right? And I can do the same thing for the other ones, right? I can kind of do, okay, this is my basic scene. Here's my dude, right? And I can use Sharex again. And I can capture that, right? Grab all this. And then I can post it and further down in my Word file, like so. And you can see that that is your second screenshot, right? You got Am Gui here, and you got your screen. You can show that this is working the way we did it. There's going to be more complex examples, guys, going forward. Don't worry. But I want to be able to do this with you now, because if we don't, then you're going to go, well, Tom, you never showed us how to do it, right? And I don't want you to feel that way. I want you to feel comfortable with the stuff that we've done, because, you know, what if I ask you for something more complex, right? Something like that. Capture it again. Here we go. 3 screenshots in a Word document, right? You can get fancier if you want. I don't need it. But if you want to, those are your 3 screenshots. It shows you differences. You've made changes. You've made the scene go. It's good to go. We're good to go with a lot. Okay, pretty straightforward. You can save this Word document, and you're going to give me the Word document with your screenshots. You're going to give me your zip archive and a link to your GitHub. You've got the lab. That's full marks for your lab right there, if you did that. All right, questions from anybody here that's with me? So I've gone through the whole process for you. So you're going to be more successful potentially. I'll also share getsharex.com. I think it's a really good one. It's a good tool that I use all the time for capturing when I make my PowerPoints. So again, highly recommend. It's a good tool. Okay. Any questions at all? Okay, great, guys. Thank you so much. If you need anything, again, please connect with me on Discord. I'm available on the regular channels that we had before. Also available via email. And remember also, oh, one more thing I forgot. Almost forgot. George Brown College. So what if I want to make it private? I didn't show you this part. If you go to settings, one last thing. And if I go to manage access, you're going to see that on the bottom, there is this thing for manage access where I want to invite teams or people. Remember, what you want to do is you want to invite me. So you want to search for me, right? And you want this one, not this one. This one is kind of one I use for business. This one here is the one that you want. You want to include me, and don't include George. I don't know who he is. This guy, all right? When you do that, you click add me to the repository. What that does is it sends me an email invite so I can work with you on the project, okay? So I can see it. And all I need from an access perspective, right? All I need from an access perspective, let me just switch my resolution so I can see it a little better, guys. I'm so sorry. I know I'm going over time. Let's go back to that. So again, if I choose me, all I need is read access, please. Okay, you don't have to give me collaboration access, just read access. Okay, and that's it. That covers everything. All right, I'm hoping you don't have any questions. If you do, connect with me. Otherwise, enjoy the week. Please remember that your assignment 1 is due 2 weeks from now, and your lab 1 is due this Sunday. All right, take care, good luck, and I'll see you next week. Take care, guys.